Yes, sir.
So if resistor has four bands color, then uh, how the fourth one will be used, that one we are going to learn, okay,
The
today.
fourth one is tolerance, right, sir?
What is tolerance?
ওই যে মানে অতিরিক্ত মানে প্লাস মাইনাস আর কি।
That means error. If the manufacturers are making, for example, 100 ohm resistor, there might be some uncertainty or error in 100 ohms. Maybe it will be 1% or 2% less or more, right? It can be 101 or 199, right? Isn't it? So
Yes,
that
sir.
time we can say the tolerance is 1%, and this tolerance can be 2%, 5%, right? That
Yes,
one
sir.
the manufacturer knows that how much contaminations there might be uh, in their process of making resistors. Then they can decide on give 1%. Okay, according to that they are giving the color code. Okay, so you write the heading now, that is tolerance. Please write this heading. Here is written tolerance, the spelling here. And you write, after writing tolerance, you write this: the fourth band, other than writing r, you write here is used to determine the uh, percentage tolerance of the resistor. Okay, then you write this word resistor.
Assalamu alaikum, sir.
Walaikum salam. Welcome back, Adnan. How are you? How was your
এখন আছি আলহামদুলিল্লাহ।
How was your tour?
হ্যাঁ, ভালো ছিল।
Was it memorable one?
হ্যাঁ, ভালো ছিল।
Okay, please write it, huh?
কিন্তু লাস্ট
Adnan?
ক্লাসে কোন পর্যন্ত করানো হয়েছে? লাস্ট ক্লাসে অবশ্য আমি করি
Adnan,
নাই, রেকর্ডিং দেখতে হবে।
we did yesterday till register color code, and we uploaded the video. You can check it there. Now you write the heading tolerance, tolerance. Okay, and after writing tolerance heading, you write whatever I underlined. Tolerance. Okay. Yeah, then after writing the above part, you write here. Right from here, the four band resistors. Normally, we don't use more than four bands. In our lab, we use till four bands. Okay, maximum. In most of the cases, we use three bands. Sometimes you will get four bands one also.
Sir.
So the fourth band is showing you the tolerance.
Sir, processor
Yes.
port is at the 4 থেকে লেখা শুরু করব?
Yeah, the four, yes.
Sir,
After process,
অন্য প্যারায় লিখব?
yeah, after process you give full stop, then you write in another paragraph. Yeah. And also write this note. If a resistor has no fourth tolerance band, then the default tolerance would be 20%.
আমি আমার ফিজিক্স খাতাই তো পাই না।
So write somewhere now. If you don't get it,
আরে হারাই গেছে।
then you take it later. So are you done with writing this part?
না স্যার, স্টার্ট করব এখন।
Okay, write quickly. Okay, Yakin, are you done with writing?
Sir, almost.
Yeah.
স্যার দ্য ফোর্থ এন্ড ফিফথ পার্ট ওইসব কি যেগুলো আন্ডারলাইন করা নাই লিখবো না ওইসব?
No, 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 no. The other things you don't need to write. Even this one you don't need for
Done,
O
sir.
levels, but for your knowledge, I'm giving you this one. For O level, you will not normally get any questions from tolerance. Okay, only you have
Sir,
to know the
done.
three
না
first
লেখা শেষ করি।
the three first color bands you have to know. Okay, now Yakin, are you done? Hopefully, right?
Yes, sir.
Okay, please read whatever you wrote about tolerance. Please read loudly.
The fourth and the fifth bands are used to determine the
Yeah.
percentage
No,
tolerance.
I did not underline here fifth. Okay, only you write about fourth. The fourth band is used. Okay, this way you write. Correct it, then
Uh,
you write.
yes, sir.
Okay, then read.
The fourth band is used to determine the percentage tolerance of the resistor. Resistor tolerance is a measure of the resistor's variation from the specified resistive value and is a consequence of the manufacturing process. The four-band resistor have tolerance of 5%, 10%, and 20%. The color code used to denote the tolerance rating of a resistor is given as brown is 1%, red is 2%, gold is 5%, silver is 10%. If resistor has no fourth tolerance band, then the default tolerance would be at 20%.
Okay, very good. Now, uh, yesterday, why we only discussed here fourth band? Because yesterday we discussed till third band, isn't it? That it is the continuation of fourth band. Is it clear to you now?
Yes, sir.
Okay, now Adnan, are you done with tolerance?
Almost.
Yeah, finish it quickly. Yeah. Then we have next one, power rating. You write the heading power rating, everyone. In your house, if you check any of the electrical appliance, then you will see the voltage. It's written the voltage,
Yes,
then
220
ampere
to
is
240.
written, then power is also written in some of the appliances.
হ্যাঁ ডান।
If you have the voltage and current, then you can find the power, isn't it?
Yes, sir.
So if for example one appliance is written like 220 volt, then current is 1 ampere, then the power rating of this appliance is 220 watt.
Watt.
Is it clear?
Yes, sir.
This way, for different appliances, we have different power rating. Okay, that means this much power can be, absorbed or can convert to electrical energy to, other forms of energy. In heater, it turns to thermal energy, right? In our fan, it's turning to kinetic energy, isn't it? So in different appliances, we have this power. That means it is also work done by time, isn't it? So that much energy is passing in every second. That is also can be expressed from power rating. Is it clear to you? Hello, hello.
Yes, sir.
Sir,
Okay,
can you
power.
repeat it
Yeah,
again? I did not
yeah,
understand.
yeah. The last part, most probably you did not get. The first part you understand. Power equals voltage into current,
Yes,
right?
yes. I
The
understood. Yes.
last part, what I said, like you can consider other formula of power, like power equals work done by time, or power equals energy by time, isn't it? Hello.
Yes, sir.
Okay, so energy by time, if you consider, then power equals energy by time. If you are thinking uh, 5 joule per second, then the power rating of the appliance is 5 watt, isn't
Yes,
it?
sir.
And
Yes, sir.
if it is like that, 500 joules per second, then energy,
500 watt.
yeah, 500 watts. So that way also you can think of that how much electrical energy is converting to other forms of energy. Is it
Oh,
clear now?
yes, sir, it is.
Okay, so here we have both the ideas. We have the linking with current, then we have the linking with voltage, then we have the linking with energy, time, everything, right? So you write this heading, power rating. Then you write the this part. Normally, we say power rating for all the appliances. Power rating of a resistor or an electrical appliance defines the maximum energy a resistor or an electrical appliance can safely dissipate.
আসসালামু আলাইকুম ওয়া
Walaikum
রাহমাতুল্লাহি ওয়া
salam.
বারাকাতুহু।
Shafi, thank
বলেন
you
স্যার।
for joining. Though it's late, thank you for joining and write please. Power
জি স্যার,
rating.
কম্পিউটার অন
Yeah,
করতেছি।
write here power rating and write this definition of power rating. Okay, then after this you write this. Resistor or any other electrical appliance components, power rating is important parameter to consider when choosing a resistor for a particular application. Okay, after writing this, you only uh, write about this too, huh? You only write about this too, huh? Appliance, appliance power.
আচ্ছা স্যার, এগুলো কি দরকার আছে?
You just have some ideas that
হ্যাঁ, লিখা।
power rating of different appliances is different. For that, I did not tell you to write all the examples. Just you write two, so that it can work in your brain. Yes, it's there. We have different power rating for different appliance. Like for example, you are using fuse in your appliance, isn't it, Adnan? Hello, hello,
হ্যাঁ
Adnan.
স্যার।
Okay, so when you are using fuse in your appliance, then it depends on the power rating of the appliance. That what type of fuse or what will be the value of the fuse over there you have to fix. Otherwise, your appliance you cannot protect properly. You cannot do it functional according to your need. Is it clear?
হুম।
Hello. So that is very important to fix the circuit breaker or for fixing the fuse in a circuit or appliance, that how much power it can take, how much load it can take. Sometimes you will see that we see that because of low voltage, uh, sometimes our fan is not moving, isn't it? Have you ever seen it in our power supply or the main supply? If the voltage is lower, then we see that fan is not moving, or the freeze is not working, or the AC is not working. Have you ever seen it?
Yes,
Hello.
it
So
happens
what?
in
Yeah,
village.
yeah. It's also a reason for this power rating, because the enough voltage or enough current you require, that is the combination of power, so that one is not coming in the power supply or in the main supply. That's why your appliance is not working. Is it clear? Hello.
Yes, sir.
And also it
হ্যাঁ
happens like in your house, maybe you can use only one AC, but you are installing two ACs. That time uh, you are using two ACs, then you are using one refrigerator, lots of things you are using. That time also you see that your circuit is not working. The circuit breaker, disconnected the whole circuit of the house. It also happens in our house sometimes, isn't it? Why? And that time we say the load cannot be taken by all these appliances. That's why the circuit is broken in the house. Is it clear? Hello, hello. Are you
Yes,
understanding what
sir.
I'm saying? So these all things are uh, you can apply, or you can do appropriately if you know the power rating of the all appliances. If you don't know the power rating,
Sir,
yes, yes,
sir,
tell me.
uh, our line has a voltage of 220 or 240. So does it mean we have unlimited current?
No, no, we already discussed in last topic, our last topic, topic 23. Hmm. So the power is fixed. Hmm. We
Oh,
can we
oh,
can we can do step up or step down, right?
yes, sir.
That time when you are doing step down, that time your current is more.
Yes, sir.
It's clear. So, and that current also you can control. You can divide. When it's coming to your house, you can control it. How much current you will give in different appliances. Is it clear to you?
Yes, sir.
We are not giving any direct AC current to our mobile. Our mobile is taking DC power supply,
DC
isn't it?
current. Yes, sir.
Our laptop is taking DC power supply. So the charger there, they are converting this AC to DC. Is it clear? There
Yes,
is
sir.
a diode. There is small instruments, equipments, electronic devices which are converting AC to.
No, no, sir. That's not what I meant.
Yeah, I understand what I said, and already you got the answer. But I am doing some extension, more explanation,
Okay, okay.
more examples are given. The question you asked me, I gave that answer. You got that one. I know, but I am extending more. Is it clear?
Yes, sir.
If you are going to take IELTS exam, then if the examiner is asking you one question, then you are only giving one sentence answer, then you will not get good score, isn't it?
Yes, sir.
You have to extend your answer. Okay, you should make more sentences. Now you know about thermistor and LDR. All of you know because already we discussed them. Huh? Action of thermistor and LDR. Could you please write this heading? Action of thermistor and LDR. And from you, you let me recall what is the property of thermistor and how does it work? Can anyone tell me, please? Hello. Hello.
Sir, thermistors resistance increases with temperature.
Thermistors
Sorry,
resistance decreases.
decreases with temperature.
Yes, both for thermistor and LDR is decreasing, right?
Yes,
But
sir.
one is for temperature increase, another
And
is
one
for
is for
light increase,
light.
light intensity
Yes, sir.
increase, right? Just you
Yes, sir.
remember, for both of them, its resistance decreases if temperature increase or light intensity increase. Is it clear?
Yes, sir.
So if you remember this way, it will be easier for you. Now, thermistor. Thermistor, uh, you you wrote this heading, right? Thermistor, action of thermistor and LDR. Then you draw this diagram only. Okay, draw this symbol and draw this graph. This graph is showing us that with increasing temperature, the resistance of the thermistor decreasing. So everything is coming here. Now, if I ask you, Moshi, if I ask you uh, one question, Moshi, are you there? Moshi, Moshi, hello, Moshi. Moshi is not. Oh, Moshi is there. Yeah. For everyone, now I am asking you, if the uh, temperature is decreasing, then what will happen to current? If temperature is decreasing, then what will happen to current in thermistor? Can anyone answer, please? Hello.
Sir, can you do the question again?
Yeah, my question is, if temperature is decreasing, then what will happen to current in thermistor?
The current will increase
The current will increase. Why?
because when temperature drops in a thermistor, the resistance decreases,
The
letting
resistance increases.
letting
Resistance increases. You already said temperature drops.
yes, sir. When
If temp
temperature drops, then resistance
in,
decreases,
in
right?
resistance increases.
Oh, I always get confused.
Now, still confused?
No, sir.
Okay, that means you are not confused. You make mistakes, right?
Yes,
You
sir.
messed up. It's not says confusion. It says messed up, isn't it? So
Yes, sir.
you messed up with it, and it should be, if temperature drops, resistance increases. That's why current will decrease. Is it
Yes, sir.
clear? So you write this point, then you can be more confident. If temperature, please write everyone. If temperature decreases, then current, then resistance of the thermistor increases, right? Hence, current through it decreases, right? Is it clear? Is it
Yes,
clear?
sir.
So, beside your that drawing, this graph, you please write it, huh? All of you, please write. Now we are discussing about light dependent resistors. Similar way, similar. Just in place of temperature, it will come light. Is it clear? Hello?
Yes, sir.
So in place of temperature, when you are getting light, that is LDR, light dependent resistor. It works in the same way. So you write here, this diagram you draw, then write what I am writing. If light intensity decreases, then resistance of LDR, we say in short LDR, light dependent resistor, LDR increases, right? Again, do you agree with the statement? If light intensity decreases, then resistance of LDR increases. Do you agree?
No, sir.
Why?
Because if light intensity decreases, the resistance, light intensity decreases, yes, then the resistance will increase.
It is correct. Do you agree?
Yes, sir. Yes,
Okay.
sir.
Hence, the current through it, current will what happened? Current decreases, right? Is it clear?
Yes, sir.
Hello. Okay. So we are done with LDR and thermistor both, right? Just you remember what I wrote. Then you can solve
Sir,
any questions coming from LDR and thermistor. Yes, yes. Tell me, please. You have any questions? You tell me.
না এখানে কোনো কোয়েশ্চেন্স নাই
Okay. Yeah. You have more
কোয়েশ্চেন্স
questions
ছিল
for
স্যার
me?
ক্লাস আজকে আগে আগে একটু শেষ করে দেন না আমার মাথা ব্যথা করতেছে
You
টাঙ্গাইল
will
থেকে
get
আসার পর জ্বরও
recording.
আসছে
Don't worry. You will get recording. Don't worry. You
না
just
আমার মাথা ব্যথা করতেছে
you
পড়ার
just
জন্য না এমনি মাথা ব্যথা
you
হবে না
just take
প্যারা নিস
rest.
না
Yeah, Adnan, you just
আম-
take rest and
হ্যাঁ
you will upload the recording. No problem. Don't worry. Yeah.
আর আমরা আছি না প্যারা নিস না কিচ্ছু হবে
Yeah.
না
Yeah. Yeah. More Shafi is there. So
তুই কে
why
রে
you are?
আচ্ছা সাফি আছে ক্লাসে আজকে
Yeah, Shafi. Thank
জি
you
স্যার
thank you for your support and strong, strong boost
জি
up.
স্যার
Okay. So you write this heading: potential divider. Potential divider. Okay. So after writing potential divider, you write this part only. Two resistors divide up the potential difference supplied to them for a cell or battery. Okay. The proportion of the available potential difference that the two resistors get depends on their resistance values. Very important. We learned it in DC circuit current electricity topic. However, we are repeating it here. We know it before. Potential divider, we know it before. But now we are using them for thermistor and LDR. That's why we brought this idea again. That time, that time we used only simple resistors. Now we will use also thermistor LDRs in potential divider. That's why we brought the idea again here. Okay? Yeah, Moshe. Moshe. Hello, Moshe.
স্যার মশির নাকি মাইক কাজ করতেছে না,
Okay, okay, fine. Then,
মানে ও হচ্ছে বলছে
Shafi,
আর কিছু বলতে পারতেছে
Shafi,
না।
Shafi, Shafi, can you read from here, Shafi, a potential divider? Hello, Shafi. Shafi, Shafi, Shafi is not responding. Then Yakin, Yakin,
Yes, sir.
please read from here, from the beginning. Then at least you will get a review of potential divider. Yeah, please.
A potential divider is a simple circuit that uses resistors or thermistor LDRs to supply a variable potential difference. They can be used as a audio volume control to control the temperature in a freezer or monitor changes light in a room. Two resistors divide up the potential difference supplied to them from a cell or battery. The proportion of available PD that the two resistors get depends on their resistance values.
Okay, look here. You are done with that writing, right? The
Yes,
underlined
sir.
one. Okay, now
Yes, sir.
we have this circuit. Look, uh, this circuit is potential divider circuit. So please draw this circuit. All of you, please draw this circuit. So if I tell you two values of the resistor, this one is 3 ohms and this one is 1 ohm. I'm talking about this one. This is 1 ohm. Then this one is power supply. Power supply is 12 volt. Okay. Then how you calculate this? How you calculate this V out? What is the formula?
So there are two ways, right?
Yeah, there are two formulas you can use, but for this one, it is we are going to find R2, isn't it?
Yes, sir.
The voltage across R2, so it will be V2. Okay, so
Yes, sir.
V out will be actually V2, isn't it? So V
Yes, sir.
out, how can you calculate here for this formula, for this circuit diagram, for these values? Can you tell us?
Using the ratio, that thing I forgot.
Okay, do you want to see the formula? Here is the formula. Can
Yes,
you
sir.
write this formula quickly?
Yes, sir.
Do it fast. So I just kept it here, huh? 12 volt, then 3 ohms, then 1 ohm. Then you find what is the value of V out. Tell me what is the value of V out.
Sir, the answer is 3.
3 volt. Yes, the answer is 3 volt. You are right. If I give this V out here, then what will be your answer?
9 volt.
9 volt. If I change this resistors, like here I am giving here I am giving 4 ohms and here I am giving 2 ohms, then what will be V out then in across R2?
V2.
Yeah, here
Sir,
for
can
R,
you write it, please, sir?
yeah,
The
for,
values.
okay, values for this one, for example, we are having 4 ohms R1, huh? And R2 is we are getting 2 ohms. Then what will be V out?
4, sir.
It is 4. Then what will
Yes, sir.
be the voltage across R1?
Voltage across R1 will be
If it is 4, then it will be 8.
8.
8 volt, isn't it?
Yes, sir.
So if you know this formula, you can find it easily, isn't it? When
Yes,
you
sir.
are going to find the voltage across R2, then you just give here R2. When you are going to the upper one, right? Only this one will be changed. If you want to get the voltage across R1, only this one is changed, isn't it? The other things are same.
Yes, sir.
So is it clear to you? All of you? Did you write this? So it is across R2, this formula. If it is across R1, only this one will be changed. It will be R1. Is it clear, everyone?
Yes,
Hello?
sir.
So that's all for today, huh? Now you have any questions, you can ask me. Any questions regarding anything, your academic, you can ask me. No questions?
No, sir.
Okay, thank you so much everyone for joining. Again, tomorrow we have class, lab class, okay? Join tomorrow.
Yes, sir. Allah Hafiz.
Allah Hafiz.